Okay, example number 4. I'm skipping example number 3. Basically, it's called Newton's Law of Cooling. It's just a big formula to know and to apply. You can look at it in your textbook, example 3, but you're not going to have to know it for quiz or test. So, I mean, it's an easy thing to do, but I don't want to make you memorize this long formula. I've done it in the past, but it doesn't matter. So, example 4. We're going to solve a log equation. Now, this here says log base 5 of something equals log base 5 of something. Okay? Those two things would have to be equal to each other for this to be true, right? I mean, if you think about log base 5 of 6 has to equal log base 5 of 6. This would have to be the same as this for these two equations to be equal, right? Same for this. If these two things are equal, then this would have to equal this, and that's the step. So all you do is you take 4x minus 7 equals x plus 5. This would have to equal this. Now you could think of it as, okay, how could you get rid of log 5? You could base 5 to both sides, right? If you said, oh, base 5 to this, base 5 to this, 5 log 5 would cancel, you'd be left with this. 5 log 5 would cancel, you'd be left with this. So in any case, you're going to come down to this. Solve for x. Minus x, so 3x minus 7 equals 5 plus 7 plus 7. 3x equals 12, which means x equals 4. There's your answer. X would have to be 4 for this to be true. So if you put 4 here, that would be 16 minus 7, which would be 9. So log base 5 of 9 equals, if you put 4 right here, that would be log base 5 of 9. It works out. There you go. Checks out. This is your answer. In this section, you're going to have to check answers again. Remember we had extraneous solutions before? You're going to have those again. So make sure you check your answer. Don't lose points because you don't want to check. Okay? Alright, example 5. What they say is exponentiate. That's the same thing as when I say base both sides. Exponentiate. I mean, that's a better word, really. Should have used that one, but oh well. Too late. Here we go. Solve this log function. So we got the log of something equals 3. Now, what do we want? What's our goal for all these equations? We want to get x by itself. To get x by itself, what do we need to get rid of? We need to get rid of log base 4. Right? That needs to be a little 4. It's a little bit bigger than what it should be, but you get the idea. Log base 4. How do we get rid of log base 4? Do the opposite of log base 4, which is base 4 to both sides, right? I got a log, so I need to base both sides. So what I'm going to do here is I'm going to base this side by 4. So 4 to this power is equal to 4 to this power. See how these sides become powers. Now, what is 4 to the log 4? That cancels out, and you're left with 1 times 5x minus 1, which becomes 5x minus 1, equals 4 to the third. You know that answer. You should. 4 to the third is 64. There you go. That was the hard part. So whenever you get a log, you want to base both sides to get x by itself. Plus 1 plus 1. 5x equals 65, which means divide by 5. X equals 5 goes to 6 once, and we got 15 left, so 3, so 13. There you go. X equals 13. You always want to make sure with these, okay? Log base 4 of 5 times 13 minus 1 equals 3. So log base 4 of, what does this become? 65 minus 1 is 64 equals 3. Is this true? Log base 4 of 64. 4 to the third equals 64. Yes, that's a check. Alright, this is your answer. Alright, example 5 is basically if you start with a log on one side and you need to get x by itself, just base both sides to get rid of that one log. But it's going to get a little harder in the next one.